Hi everyone, welcome to our class. Today I am going to discuss the differentiation formulas. And at the end of this video, you are expected to be able to recite the differentiation formulas such as the derivative of constant, sum, product, quotient, the power formula, and the derivative of the radical. You are also expected to be able to apply appropriate formula in finding the derivative of a given algebraic function. We are now going to discuss the basic differentiation formulas. So in the succeeding formulas, you will encounter variables such as u and v. So this variables represents function of x. We have the first formula is the derivative of a constant. So before we'll have the derivative of a constant, let us recall first the graph of the equations y is equal to 3, y is equal to negative 4, and y is equal to 0. So I hope you still remember in your analytic geometry that the graph of a function or any function y is equal to a constant is a horizontal line, and that all horizontal lines have slopes equal to 0. So in our previous discussion, we have defined the derivative of a function is equal to the slope of the function. And so therefore, if the function is a constant, that will give us now the derivative of a constant is equal to 0. So in symbol, we have the derivative of a constant with respect to x is equal to 0. Again, this variable found in the denominator in the symbol derivative d over dx tells us that the independent variable is x. So we memorize this formula as the derivative of a constant is 0. The next formula is the derivative of x. So recall again in your analytic geometry that the graph of the function y is equal to x is a straight line inclined upward to the right, whose ratio of the change of vertical and the change of horizontal is equal to 1. Or we can compare this equation with the standard form of the straight line y is equal to mx plus b, where m is the slope of the line. So in this equation, the coefficient of x is equal to 1. That means then that the slope of the function y is equal to x is equal to 1. Hence, we have the formula. The derivative of x with respect to x is equal to 1. We have the symbol, the derivative of x with respect to x is equal to 1. The next formula is the derivative of sum. So when we talk about sum, we are referring to a function containing two or more terms. So we recite the formula as the derivative of a sum is equal to the sum of the derivatives of each term. So in symbol, we have here the derivative of u plus v is equal to the derivative of u plus the derivative of v. Again, the derivative of sum is equal to the sum of the derivative of each term. The next formula is the derivative of product. We recite the formula as the derivative of a product is equal to the first factor times the derivative of the second factor plus the second factor times the derivative of the first factor. So in symbol, we have here the derivative of a product. The product is we have u times v. We call u as the first factor, v as the second factor. So applying the formula, the derivative of product u times v is equal to the first factor, which is u, times the derivative of the second factor, plus the second factor, v times the derivative of the first factor, u. So that's derivative of product. So if we are going to find the derivative of a product wherein one factor is a constant, applying the same formula, that will give us now the first factor, which is c, times the derivative of the second factor. you will notice that the second term, which is the second factor times the derivative of the first factor, since the first factor is c is a constant, that means in this formula, the second term will now be equal to 0. Hence, we have the derivative of a product with a constant factor is equal to the constant factor times the derivative of the second factor. I am now going to discuss the basic differentiation formulas. In some of the formulas, you will encounter variables such as u and v. Remember that these variables are functions of x. So we have here the derivative of a constant. Before we go to the formula, let us recall first the graph of the equations y is equal to 3, y is equal to -4, and y is equal to 0. If you still remember in analytic geometry, equations in the form y is equal to a constant will give us a horizontal line. Also, we learned in geometry that the slope of a horizontal line is 0. Since we already know that the derivative of a function is equal to its slope, then we say that the derivative of a constant is equal to 0. So we have now this symbol. The derivative of a constant is equal to 0. The next formula is the derivative of x. Again, going back in our analytic geometry, y is equal to x will give us a straight line. The graph of y is equal to x is a line inclined upward to the right, such that the ratio of the change of vertical to the change of horizontal is equal to 1. Or if we are going to compare this one with the standard form of the straight line, y is equal to mx plus b. M, which is the coefficient of x, is its slope. So in this equation, y is equal to x. The slope is equal to 1. So since slope of a function is equal to its derivative, then we say the derivative of x with respect to x is equal to 1. In symbol, we have here the derivative of x with respect to x is equal to 1. The next formula is for the derivative of sum. So when we talk about sum, that means we have a function involving two or more terms. So the formula is the derivative of a sum is equal to the sum of the derivative of each term. So we have the derivative of the functions u plus v, which are both functions of x. So the derivative of sum is equal to the derivative of the first term plus the derivative of the second term. The next formula is the derivative of product. So when we say again product, that means we are multiplying functions. So we recite the formula as the derivative of a product is equal to the first factor times the derivative of the second factor plus the second factor times the derivative of the first factor. In symbol, we have here the derivative of product. We have u times v. U is the first factor and v is the second factor. So we say the derivative of product is equal to the first factor times the derivative of the second factor plus the second factor times the derivative of the first factor. Now, if one factor is a constant, say the first factor u is a constant, so we have the derivative of c times v. Applying the same formula, that gives us the first factor, which is c, times the derivative of the second factor, plus the second factor times the derivative of the first factor. But since the first factor is a constant, that means in this formula, the second term becomes 0. Hence, we have the derivative of a product with a constant factor is equal to the constant factor times the derivative of the remaining factor. We also have the derivative of quotient. So when we say quotient, we are referring to a function containing a numerator and a denominator. So we recite the formula as the derivative of a quotient is equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the square of the denominator. In symbol, we have this, the derivative of quotient. So the quotient we're referring to is u divided by v, or u over v. The derivative of a quotient, u in here is the numerator and v is the denominator. So in symbol, we have the derivative of quotient is equal to, so you draw the division line. You have the denominator, which is v, times the derivative of the numerator, so you have du over dx, minus the numerator, which is u, times the derivative of the denominator, all over the square of the denominator. Now, if in cases you have a fraction or you're taking derivative of a quotient where the numerator is a constant, notice that in this original formula, this factor derivative of the numerator, which is a constant, becomes 0. So what is left is we now have the derivative of quotient with a constant numerator will now be equal to the negative of the constant numerator times the derivative of the denominator all over the square of the denominator. The next formula is the general power formula. The formula states that the derivative of a power is equal to the exponent times the base raised to its exponent minus 1 times the derivative of the base. So when we say power, we are referring to a function in the form base raised to an exponent. So here in our function, we have u raised to n. So the derivative of a power is equal to the exponent, which is n, times the base raised to the exponent minus 1 times the derivative of the base. So we have special cases when the power formula is applied. First is if the base u is equal to x. So that the power formula now becomes the derivative of x raised to n. So applying the power formula, this will be equal to the exponent n times the base x raised to n minus 1 times the derivative of the base. So we have dx over dx. We know that the derivative of x with respect to x is equal to 1. Hence, we have now the formula, the derivative of x raised to n is equal to n times x raised to n minus 1. Another is if the exponent n is equal to 1/2. So our power formula now becomes the derivative of u raised to 1/2. Applying the power formula, it gives us now the exponent 1/2 times the base raised to the exponent minus 1 times the derivative of the base. So simplifying this function now, that will give us the derivative of u raised to 1/2 is equal to 1 all over 2 times. We know that u raised to 1/2 minus 1 becomes u raised to negative 1/2. And it becomes a factor u raised to 1/2 in the denominator. So we have times derivative of u with respect to x, or simplifying this one further, we know that an exponent 1/2 may be written in radical form as square root. And so we have now our derivative of the radical. That is, the derivative of the radical is equal to the derivative of the radicand divided by twice the radical. It is important to note that the radical we are referring to in here is applicable only for square root. So you have the derivative of the square root of u is equal to the derivative of u all over twice the square root of u. It is now time to apply the basic differentiation formulas that we just discussed on finding the derivative of functions. So let us have this problem. From the function y is equal to x squared minus 2x plus 3, find the derivative of y with respect to x, and that is denoted by the symbol dy over dx. So to start our solution, from the function y is equal to x squared minus 2x plus 3, we are going to find the derivative of the left member with respect to x and find also the derivative of the right member with respect to x. So again, recall that in working with equations, whatever you do in the left, you do the same at the right side. So the derivative of y with respect to x may now be written as dy over dx, and we look at the right member. We are going to find the derivative of this function. So you have to read properly the function following the derivative for us to be able to identify the appropriate formula, differentiation formula that we can apply. So we have here the derivative of x squared minus 2x plus 3. So you will notice in here that the function involved three terms. So what we are going to do is apply the derivative of sum, which states that the derivative of sum is equal to the sum of the derivative of each term. So what we're going to do is just get the derivative of each term. So you have derivative of x squared minus the derivative of 2x plus the derivative of 3. So further, we simplify the function as we have our derivative of y with respect to x is equal to. Notice in the first term, we have here the derivative of x squared. So again, we go to the list of the differentiation formulas that we had. We have this formula, the derivative of x raised to n is equal to the exponent n times the base raised to the exponent minus 1. So for the derivative of x squared, we now have the exponent 2 times x raised to 2 minus 1, that is x. So we are done now differentiating x squared. Minus, the second term in here is derivative of 2x. 2x means 2 times x. That means we are going to find for the derivative of product with a constant factor c. So the formula is derivative of product with a constant factor. Please just write the constant factor outside and then multiply the derivative of the remaining factor. So in minus the derivative of 2x, we factor out 2, then we have the derivative of x with respect to x. In the third term, we have the derivative of 3. And we know we have this formula for derivative of constant, and that is equal to 0. Since 3 is a constant, the derivative of 3 then is equal to 0. So we now have derivative of y with respect to x. Those terms which do not contain derivative, we just copy. So we have here minus 2, and derivative of x with respect to x is equal to 1 plus 0. So you don't need to write that 1 anymore. That gives us now the value of the derivative of y with respect to x is equal to 2x minus 2. Let us solve the next example. From the function y is equal to the quantity 1 minus 2x raised to 3, find the derivative of y with respect to x. So we start our solution by finding the derivative of the left member with respect to x. That is equal to find also the derivative of the right member with respect to x. Again, whatever you do in the left member of the equation, you do the same at the right side. So the simple derivative of y with respect to x may be written as dy over dx. Then at the right side, we have here the derivative of this quantity raised to 3. So the function following the simple derivative follows the power formula. You have in there in the left side of the power formula, derivative of base raised on exponent. We have here the given derivative of base raised on the exponent. So applying the right side of the formula, we now recite in the next step, you write the exponent, and the exponent in here is 3, times the base. So here the base is 1 minus 2x. So we have 1 minus 2x raised to the exponent minus 1. So we have 3 minus 1. Then times the derivative of the base. So we have times the derivative of the base, which is 1 minus 2x. So in the next step, we just copy those factors which do not contain derivative and simplify. So we have here 3 times the quantity 1 minus 2x raised to 2. So this we have the derivative of 1 minus 2x. We go back again to the list of differentiation formulas and notice that this follows the derivative of sum. We have here derivative of two terms, 1 minus 2x. So applying the right side of the formula, derivative of sum is equal to the derivative of the first term plus the derivative of the second term. So this will give us now the derivative of 1 minus the derivative of 2x. Okay, so simplifying further, we just copy 3 times the quantity 1 minus 2x raised to 2, and we have again in here derivative of 1. Since 1 is a constant, we again apply the formula, derivative of a constant is equal to 0. So we have there 0, then we have minus the derivative of 2 times x. So we apply the formula for derivative of product with a constant factor, where we just have to factor out the constant. We have so minus 2 times the derivative of x with respect to x. So we simplify further. We have here 0 minus 2 times, we know that the derivative of x with respect to x is equal to 1. And so finally, we have the derivative of y with respect to x is equal to negative 6 times the quantity 1 minus 2x raised to 2. Let us solve another example. From the function y is equal to 2x plus 5 all over 3x minus 1. Find the derivative of y with respect to x. So again, we follow the same process. We find the derivative of the left member with respect to x. We find also the derivative of the right member with respect to x. So that the derivative of y with respect to x is written as dy over dx. Then we read the right side. The derivative of 2x plus 5 all over 3x minus 1. Then go back to the list of the differentiation formulas. Try to compare what formula does it follow. So we have here derivative of, this is a quotient, so we apply derivative of quotient. So the numerator is the 2x plus 5 and the denominator v is the 3x minus 1. Recite the right side of the formula, write its value in the next step of the function. So we have the derivative of quotient is equal to, you draw the main division line. Then we start with the denominator, which is 3x minus 1 times the derivative of the numerator minus the numerator times the derivative of the denominator all over the square of the denominator. So we continue our solution. Those factors or terms which do not contain derivative will simply be copied. So we have there 3x minus 1, then times the derivative. So we go back again to the list of differentiation formulas. This is derivative of 2x plus 5. It is a sum. So we apply the derivative of sum. And that is equal to the derivative of the first term plus the derivative of the second term. Then we have here minus the quantity 2x plus 5. Again, this one starts with derivative. We have derivative of 3x minus 1. Again, it involves sum. So we'll take the derivative of the first term minus the derivative of the second term. So as we continue, we copy those terms or factors which do not contain derivatives. So we have the quantity 3x minus 1. We have here derivative of 2x. Again, 2x means 2 times x. So this is derivative of product. So we just factor out 2 and then the derivative of x with respect to x is equal to 1. Plus the derivative of 5. We know 5 is a constant and so its derivative is 0. So we have here 0. Then minus the quantity 2x plus 5, we just copy. Then derivative of 3 times x again is 3 times. The derivative of x with respect to x is 1. So we have 3, this is minus derivative of 1. Since 1 is a constant, its derivative is 0. So we are done differentiating the function. What is left is just dy over dx. So all we need to do is simplify. That gives us now 3x minus 1 or the quantity 3x minus 1, 2 plus 0 is equal to 2, minus the quantity 2x plus 5 times 3. So we simplify, that gives us now, we distribute 3x times 2 is 6x, negative 1 times 2 is minus 2. This is minus 2x times 3 is minus 6x. This is minus 5 times 3 is minus 15. Combining similar terms, 6x and this minus 6x cancels out. So what is left is the derivative of y with respect to x is equal to negative 17 all over the square of 3x minus 1. Let us solve another example. Find the derivative of the function y is equal to the square root of 2x minus 5. So again, we start our solution by finding the derivative of the left member with respect to x. Find also the derivative of the right member with respect to x. So the derivative of y with respect to x is written as dy over dx. The right side, we have here the derivative of the function following the derivative is the square root of 2x minus 5. Again, as we look at our list of differentiation formulas, derivative of square root of 2x minus 5 follows our derivative of radical, where the derivative of square root of u or derivative of radical is equal to the derivative of the radicand all over twice the radical. So following the formula, this derivative of radical, that will give us now a fraction. The numerator is the derivative of the radicand, that's 2x minus 5, all over twice the radical. Then we simplify. We just copy the denominator and the numerator, we have their derivative of 2x minus 5. The function following the derivative contains two terms. So we apply the derivative of sum, which is the derivative of the first term minus the derivative of the second term. Simplifying further, this will give us the derivative of 2x is 2 times derivative of x with respect to x, and that's equal to 1. So we have 2 minus the derivative of 5 with respect to x. Since 5 is a constant, that will give us 0. We just copy the denominator. Simplifying further, we now have the derivative of y with respect to x is equal to 2 all over 2 square root of 2x minus 5, or the derivative of y with respect to x is equal to 1 all over the square root of 2x minus 5. Let us solve now this example. Find the derivative of the function y is equal to the cube root of 3x squared minus 1. So we start our solution by finding the derivative of the left member with respect to x, and we do the same at the right side. So we have the derivative of the cube root of 3x squared minus 1. So we have here dy over dx. And as we differentiate this function, we go back again to the list of differentiation formulas that we had. So we have here the derivative of cube root of 3x squared minus 1. So you will notice in the list there is no formula for finding derivative of cube root. You have to be careful. The formula that we have for the derivative of radical is applicable only for the square root. So since there is no formula for the derivative of cube root, we have to find ways in writing this function in another form. So in algebra, the cube root may be written in power form, and that will be equivalent to the exponent 1/3. So we therefore have the derivative of the cube root of 3x squared minus 1 may be written as the quantity 3x squared minus 1 raised to 1/3. So with this function now written in power form, we are now ready to apply the power formula, where the power formula states that the derivative of base raised to an exponent is equal to the exponent times the base, which is 3x squared minus 1, raised to the exponent minus 1, times the derivative of the base. So as we simplify, we just copy those factors which do not contain derivative. We have here 1/3 times the quantity 3x squared minus 1, and 1/3 minus 1 is negative 2/3. Then we have here derivative of 3x squared minus 1 that contains two terms. So we apply derivative of sum, and that will give us now the derivative of the first term, which is 3x squared, and we have 3 times the derivative of x squared, applying the derivative of product, minus the derivative of 1. So we have, simplify again, the derivative of y with respect to x is equal to 1/3, 3x squared minus 1 raised to negative 2/3, and we have 3 times the derivative of x squared is 2x minus the derivative of 1 is 0. So we are done differentiating, we just simplify further. We have 3 times 2x is 6x. 3 and 6 cancels out. That will give us now the derivative of y with respect to x is equal to 2x times the quantity 3x squared minus 1 raised to negative 2/3. By this time, you must already be familiar with the basic differentiation formulas. However, the best way to memorize the formula is to recite each as you apply it in the differentiation process. Thank you for watching. I hope you learned something.